Hello everyone. So today we are with our new contest, which is Codeforces Round 772, Div 2, and yeah, it is going to start within a couple of seconds. So let's set up the my OBS. Okay, fine. And another thing is like it is going to start. I hope that it will go well. And let's see today how is the question will there. We will try to do as fast as possible. And yes, it is going to start. All the best to you all. Fine. So, okay, fine. It's open. So, let's see. It is little bit slow today. It is opening right now. Yeah, let's open the things. Fine. And okay, fine. So, what the question is that each disk multiple. Fine. The first line of each disk is contain an integer size of the array. Okay. The second line of each disk is okay. Uh, Fine. For each disk is print one number in a line. So, okay. For each test case, print one number in a line, the minimum possible sum of the array. Possible sum of the array. Okay. So you are given an array A of size n. Fine. You can perform the following operation in the array. Choose two different integer ij, and replace ai with x and aj with y in order not to break the array. Fine. And okay, it's or operation should be equal, must be held. Whereas this denotes the bitwise OR, and note that x and y are non-negative. Non-negative. Okay, fine. And please output the minimum sum of the array you can get after using the operation above any number of times. Fine. And here this like number is like low only, means like okay, we can do brute force also. And 2 to power 30. What does it mean? Like it could go till 30 bytes. Fine. It is also clear that it could go 30 bytes. So we have to choose so that our sum would be minimum. So OR operation. It's an OR operation. So if we take 0 0 for every, it's not possible. Uh, First example, you can perform the operation to obtain the array. Okay, choose 1 and 2. It will give you its value, since 1 3 is equal to 1 2. The array will become 1 2 2. Okay, change A1 to 1 and A2 to 2. Okay, so that it's fine. Again 2 and 3 and A0 and 2. So it will give us 2, and yeah, 2 and 3 is like 2 only. Fine. Okay, so we can prove the minimum sum is 3. Second case, 1 2 4 8 16. In this cases, Yeah, like it would increase only if we do this type of things also. 66356. 6 and 6356. 6 will give us 6 only. And okay, let me open my OneNote to better understand this one. So 6 and 6. If we do OR operation of any number like a of I, a of j, so OR operation. So it will be like that number, that small number would be there only. Fine. Their bit would not change and above one will come, so it will also contribute. Fine. So how we can reduce the things? Fine. That's the point. So 132. So it's 0, 0, 1, 3, 0, 0, 1, 1, 0, 0, 1, 0. So this only, and if I'm doing this also, it will increase. Ultimately, the bit will not change, and whatever the number we will take. So they had taken this, which is giving them 3. Fine, max bit in them, and they had replaced this with 1 and 2. Hmm. Even will increase. Fine. If we talk about 6 and 6, so what they had did, 6 and 6 or would be 6 only. Fine. What could we do another one? They are giving 12. 6 is 3 plus 3. It will give us 6. Mm, fine. 3, 5, and 7. 11. 14 divided by 2. 7. 12 divided by 2. 6. 6 divided by 2. 3. Okay, okay, I'm getting something. And here every number is like, okay, I should add this and divide by 2. Okay, okay, fine. So yeah, I will do this. Let's start doing this. So let me code it. So what I'm going to do, LLN, uh, okay, and yeah, I'm going to insert inside that vector. I'm going to store this. Why to declare a vector also? Like I can do directly this. Why to declare a vector? I need just some zero. So yeah, sum would be sum equal to sum is equal to x, and I will also check that x. Wait a second. X, x minus 1, x into x minus 1 if they are giving 0. It is a condition for checking that it is a power of 2 or not. So we enter our int equal to 3 int plus, and after that sorry, I will if cnt equal to n sign c of sum handle as c of sum divided by 2. Let me check this. 331. 1 minute. Okay, so yeah, 1 minute. Let me check it out. CNT is giving what? Here in this operation 3, 4, 5. Only one CNT. How is it possible? Yeah, now it is giving correct answer. So fine, that's great. I think this would work. So let me submit this. Wrong answer of pretest 2. Oh, hmm, what logic I was missing? It is like getting. I think the logic is 5, 6 divided by 2. minimum sum. So any OR operation, if we do 16 means it would take 4 byte to keep over 4. Okay, 5 byte it will take. So placing this with any number is like so difficult. 6 12 divided by 2 they are doing. As they are replacing 6 2 3 and 3. There would be 4 5 6 divided by 2. I am seriously not getting what I am doing here. One, 3, and 2. 6 1. Okay, its OR operation should be same. Any two elements or operations should be same so that only we can replace this. Byte of 6 is 2. Bit of 6 is what? 4. Nearest is 4. And rest what left? 2 is left. Okay. 1 and 2. 3 is the largest number and 3 is near to 2 and plus 1. 3. Then if we talk about 6, 6 is the largest number here. So would be 4. 16 is what about 2 raised to power 4, which is 16. 2 raised to power 5 minus 1 they did. And if we talk about 6, so 2 raised to power 8 minus 1. Talk about 8 minus 1 they did. 4 minus 1. 2 raised to power n plus 1 minus 1. Raised to power n plus 1. 2 raised to power n plus 1. How it could be like literally not striking anything right now. 2 raised to power 1, 3, and 2. So mm, to power 3. 6 is like 8 minus 1. Or operator. How we could minimize the or operators? Here I am seeing that if I do uh, the or operation of all things, so they are giving some. Fine, let me see right now. Mm, okay, so let me go there. Sum of all of sum of all of or operator. Fine. Okay, I mess up this question. It is the means like sum of all operators. Okay, no problem. We kept behind, so behind. Fine, no problem. We will do good. Okay, so let's solve the fine. Second question. What this question is saying? This question is saying like we have each test case contain multiple test case. First line will contain a single integer. The number of test case follow. The first line of each test case contain okay and size. Okay. For each test case, first output a line containing a single integer m. First output a line containing a single integer m. Uh, First output a line containing number of operation required. The output of line consists of n integer. The resulting array after the operation. This array should differ in exactly m elements from the initial array. Okay. We are given an array A of size n. Okay, we have given an array A of size n. Each element in this array is an integer between 1 and 10 raised to the power 9. Okay. You can perform several operations to this array during an operation. You can during that operation you can replace and okay you can replace an element in the array with any integer from 1 to 10 raised to the power 9. Output the minimum number of operation needed such that the resulting array doesn't contain any local maxima. It doesn't contain any local maximums. Fine. And the resulting array after the operation. Okay. Uh, an element AI is a local maximum which is strictly larger than both of their neighbors. Since A1 and AN have only neighbor each, okay, so they will never be a local maximum. We have to do operation so that our local maximums will reduce, or we can say it's like no okay uh, okay, we have to do the operation such that local after doing that operation local maximum would not exist. We need to replace the elements. Fine. So let me do this in my notepad and yeah, I did any local maximum sums. Yes, so basically what we need to do, basically we need to arrange the items just like that. Mm, in descending order we can say. Fine, in descending order we can say. Yeah, in descending order. Indirectly we have to arrange the item in descending orders. So if we talk about 212, means what is local maximum? This type of thing is local maxima. So 212, from here if we go it decreased and again increase. So no effect. 2120 operation. Then 1231 Yeah, here is one row local maxima. So we'll check that this replace this. If we go here and if we see that both are there, which are okay, no problem. This both are less than. So what I'm going to do, they had okay. I'm going to do like I will place this two again. So no problem would be there. Like this, if I do, and if I see one, two, one, two, 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 one, no, one, two, three, three, two, three, three, two, one. So okay, no problem. Here it's no problem. Here 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 no problem. Oh, they said there is a problem. Please not. Two. Okay, okay, sorry, I was seeing this. Sorry, sorry. One, two, one, three, two, three, one, two, one. So here it's an problem. So I will replace this one. Fine with this. Okay. Now I'm seeing in this, no problem is there. Seeing this, yeah, it had some problem. So I'm going to replace this with this three. Here I'm seeing no problem. 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 Yeah, here also one problem is there. So replace this with 3. So for this, they are taking one replacement I did here, and another one, 1 2 1 3 2 3 1 2 1. One problem is there. So I replace this with 2. Let me say 2. I replace this with 2. After that, what will happen? Okay, no problem. Here, no problem. Here is a problem. Yeah, here it would be a problem. So for minimum case, what we need to do? We need to replace this element with beyond this one. Fine. So it would be 3, 3. Okay, fine, fine. I got it. So 1, 2, 1, 3, 2, 3, 1, 2, 1. So we will replace this 1. Okay, 1, 2, 1. Okay, here we point out it. So we will replace this with this. Fine. Here we reach. Fine, no problem is there. Reach, no problem is there. Here we reach. Yes, there is a problem. No, no problem is there. Yeah, there is a problem. So I would replace with 2. Here I reach. No problem, it is there. No problem. Okay, like this we have to do, and yeah, we can do this easily. And what are the cases? Like we will loop from where? From here to from here, and from here till here we can see that there is a problem or not. Fine. On the basis of that, we can replace. Else, this we can check it out. Okay, okay, no problem is there. Okay, so let me code this. So 1 minute. Fine. So where it is? Okay. So LL of MP, it is okay. I think this. Okay. Now wait a second. Yeah. Now it's fine. So we will vector. Vector. I am taking the input in a vector and we have taken the input. After that, what I am going to do, I am starting a loop from I equal to from where I I less than into n minus I plus plus. It will not go till end, and I will check that if I is not equal to n minus 1, minus 2, sorry, minus 2. So in that case, yeah, we need to go till only this one, only n minus 2 only. No need to go till there. Let it, let it be. So what we will check if p of I is greater than p of I minus, and simultaneously it is p of I is greater than p of I plus 1. If it is greater than, so what we will do? We will replace that v of like I plus 1 with v of I plus 2. Yeah, but once a minute. How? Means maybe possible that this number is also smaller, like 3. In this case, it is bigger than this, but yeah, it could be a smaller number. We don't know about this. Okay, so let me again see this. So, okay, this number should be greater than both of them. This number should be greater than both of them. Fine. So I will take the max between them, and yeah, max between them I can do. Max of v of I, v of a plus. Okay. So this would be this, and yeah, whenever it would come, so it will count to plus. Since it is changing, and let's put value 20 0. So okay, it will do like this, and I will print uh, 20, and I'm going to print this vector. See how and handle would be like this. Out. So yeah, it would work. Our logic is strict. Fine. So 0 to 1 2 fine, 1 2 1 2 3 1 3 3. That's cool. Okay, what they did? 1, 2, 3, 3, 3, 1. So it looped till here and it had checked that this is okay and count plus 1 and v of I is max of v of I. Find this number and I plus 2. I can check that if I plus 2 equal to 1 minus 1, not be n minus 1. Fine. And an n minus 1, so I think that v of I plus 1 is like okay. You can write this is equal to v of I. Fine. So that also will work without any problem. Yeah, 1, 2, 3, and 1, 2. Okay, here it had taken the max of 2, so yeah, then it's fine. That okay, it's good. 3, why it had taken 3? So 1, 2, 1, 1, 2. I said max of. Okay, if we dry run this, it had reached here 2. Okay, if we dry run this, so it had reached here 2, and v of I, okay, both are from both it is greater. After that, what? Count 1. Yeah, 1 first. What we need to see? Okay, it's not also. Then, then what? V of I plus 1. V of I plus 1 plus 1. 1 plus 1. This max between V of I plus 1 is what? 2. V of 2 is max of V of 1. Find max of V of 1, max of 2, and V of 1 plus 2. 3. Max of this is what? 3 only, no? Why it is not coming? Wait a second, like I'm coming. Sorry for disturbance. If I see V of I plus V of I plus 2 and L become 3. Let me take this case only. Logic is correct only, so why it is giving me wrong? Not getting. Think I something here 588. Oh, okay, it hadn't entered. Okay, it had entered plus two. See that if I plus equal to minus 1 means like I plus 2 is like what? No, no, like it's equal to n. If it is giving me n, so on that case, what you need to do, like just replace this p of I with what? V of I. Fine. So I think else everything is fine. Okay, now it's good. So let me check it out. Everything. Okay, fine. Now I feel that no logic behind this. Another no such more logic would be there. Let me check the edge cases here. If I check it out like and I will put a 2 is not possible. It's okay. So yeah, and I think everything is fine. And any case where it could fail, we can think or not. Like, is there any cases where it could fail? Hmm, I think it would be fine. So let me submit this question. Okay, okay, fine. It had passed the pretest. And if I see, okay, let me see the C question here. This question is saying to us differential shorting. The question is of differential shorting. Each test case contain multiple test case. The first line will contain a single integer number of test case. Then T test case follow. Okay. The first line of each test case contain a single integer and the size of the array. Okay, this is the element of A. Fine. Second line of each test case contain n integers. It is guaranteed the sum of n over all test case. Okay. We are given an array for each test case print minus 1 in a single line if there is no solution. Okay. Otherwise, in the first line, you should print an integer m, the number of operation you perform. The ith of the following m lines, uh, what the ith of the following m line should contain the integer xyz description of the ith operation. Fine. So 3 is there. Okay, so note that you don't have to minimize the number of operations. So let me see what the question is saying. Given an array A of n element, you can perform the following operation no more than n times. Fine. You can perform the following operation no more than n times. More than n times. Perform the following operation no more than n times. Hmm. Select three indices x, y, z and replace ax with ay minus z. After the operation, ax need to be less than this. Replace okay. Select three indices x, y, and z. Fine. You have to select three indices and replace ax with ay minus az. After the operation, mod ax should be okay. The goal to make the resulting array non-decreasing means it's in increasing ascending order. If there are multiple test cases, you can output any. If it is impossible to achieve, you should report it as well. Fine. So, okay, we need to sort the array in ascending order indirectly. And yeah, if we see the constraint, we have to optimize in O of n. It's nice. X, Y, Z. We can take the indices, any of the indices we can take. Fine. Okay, fine. And if we see here, 5 minus 4, 2 minus 1, 2. So, what indices they had taken first? Okay, so in this thing, 5 is bigger than minus 4. So, they perform the operations minus 4 and 2. So, minus 2 would be there. So, it had come there in first operation. So, minus 2. Sorry, minus 6, minus 4 and minus 2. It's become minus 6, minus 4. Then they again perform the operation 3 and 4 and 5. So it will become okay 4, 3 and 2 if it's in descending order. Why? In descending order, it is impossible to achieve it. And if we had taken n minus 3, minus 2, minus 1, minus 3, okay, it's an ascending order, so zero operation. Fine. Oh, okay, so let me see this how we can do. Here the thing is what our intention is like to sort the array. We need to sort the array and if we break the question, if it's already in ascending order, so zero operation, descending order not possible, and if it's and normal, so we have to do operations and convert it to this. Fine. 5 minus 4, 2 minus 1, 5 is bigger than this. So 1 is no problem. Yeah. So if we convert this if it's an already negative number, okay, so how we can do this? We need to short the things, replace the things. Condition is like it should be something like this. What basically non-shorting is? What basically non-shorting is about? Uh, like what we can say that if this array is not shorted, like what would be its graph? Its graph is like this, 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 this. Such type of graph is there. So basically, what we need to do is like to we have to perform some operations and minimize the local maximas and minimas. Fine. Like this, we have to do not minimize. Like we have to do some operations and means vanish this maxima minima. Fine. Uh, so yeah, it would be better. So, 2, 3. It's an unsorted one. Fine. So what could it would be like 6, 4, 2, then 5, 3. We need to replace this. So for that, what 5? Okay, then it would be this is bigger, this is bigger 2, and here if we see 3, 3 operation. Total 3 operation we have to do. 3 operations we need to perform. Hmm. To do this. We need to perform total 3 operations. How we can do this 3 operations? And let me see that it is possible or not. This is a major concern. So 6, we have to minimize 6 such that it would be less than this 4. It would be less than 4. How we can perform this? So if I do 4 and 2, 4 minus 2, so it will give me 2, 4, 3, 5 and 3. Yeah. Okay. Now if I want to less than this, so I will perform like 2 minus 5. It will give me minus, yeah, but the condition is like it should be greater than 2 also. Yeah. So 2 also. How we can do this? It would be like this. So yeah, it would be fine. But like this, it is coming. It is like this. If we observe the graph, yeah. So if the condition of the graph is like this, so we can easily this replace this by means like uh, so that it would become like this minus this. So it is obvious like it would be somewhere here. And from here, if it is like this and like this, it means above this also. So yeah, again we can do this type of things. Should be greater than this. Yeah, how we can do this? Prefix sum, suffix sum here. I don't think it would be. What basically what we need to do is to replace an element, any of the element x with a of y minus a of z. 5, 6, let me see, 6, 4, what we had taken, 6, 4, 2, 5, 3. We can do this or not? 2 minus 5 minus 3. Okay, 4, 2, 5, 3. It is coming again. We can replace this with 5 minus 2 minus 3. Okay, then this 2 and 5. Okay, no problem. Then uh, 5 and 3. Then 5. 5. We have to replace this. So for that, what we will do? We need to replace it. So okay, minus 3. We do here replace 4, no? So 3 minus 2, 1. Then 2. Then 5. Then 3. So we can replace this 3 minus 1, 2. Like this, we can do. We can solve the things. Great. If it would be like 6, 4, 2, 6, 4, 3, 2, then some uprights, then some like 5. So it is possible or not? So if we see this here, yeah, it would be possible like if we do 5 minus 3. 5 minus biggest number 5 minus 2 minus 5, it will give me 3. Yeah. Then 4, so we can replace 4 with what? Replace 4 with what? 2 minus 4, that's minus 2. And if we see a 3, we can replace 3 with what? No, like 6 minus 3. Fine. 5 minus 6 is okay. 5 minus 2 is minus 3. 4. So we can replace this with uh, hmm, replace this with 1. Let me take 3 minus 2 is 1. No, 2 minus 3 is minus 1. Then 3 we can replace with what? It's giving me 3. So okay, so let me do this one. Then 4 minus 2 is 2. And yeah, 2, 5. We can replace this 5 with what? Yeah, it is fine. Yeah, everything is possible. Okay. How the things are going on? Let me see. If we short this array, if we short this array, so okay, how it would become? It would become like 2, 3, 4, 5, and 6. Fine. Hmm, what the thing which is basically going on? We don't need to minimize this as much so that we can't able to take this. No, we can take this. 1 minute. If we talk about 6, 4, 3, 2, 5. 5 minus 6, like okay, minus 3, 2, 5. So 5 would be like 2. Let it be minus 3. Again minus 3, 2, 5. We won. We won. uh, yeah, 6, 4, 4, 2, 5, 3. 6, 4, 2, 5, 3. So it would be like 6, 4, 2, 5, 3. 5 and 2 is minimum. Okay. 6 64253. So if we do minus 3 2 5 3 2 5 and 3. So yeah, minus 3 will become minus 3 0 5 3. Then it would become 3. Yeah. So what the thing we need to learn it from here? 6 4 2 5 and 3. Such case is there. So we take this. Okay, so if I take 5 minus 4, 2 minus 1 and 2. So what I'm thinking, if I insert this element in heap, fine. If I take this all elements in heap, okay. So minimum of this is like minus 4 and maximum of this is 2 minus 6 minus 4 2 minus 1 2. Then this, so we pop out this. If you see this, so maximum of minus 2. So it is giving me minus 6 minus 4 minus 3 minus 1 2. Hmm. What I was thinking is to insert every element in heap. Fine, min heap and max heap. Every element means like from this to this. We will check. Yeah, should put this. So listen, my logic is to Insert from here, from first element, from second index to last index in max heap and min heap. And after, if I see that if I saw that, like, yeah, so our operation would also increase, so no problem. Our operation problem is not there. If I see this 5, minus 4 and 2, minus 6. 5 is replaced by this. Then minus 4. But the problem is that it the heap would not, like, we have to say that heap, like, you have to remove this element after this. This element after this, yeah. This is required essentially. Minus 4 is removed and 2 is also removed. So it will give me minus 1 and 2 plus 1. Then from here, if I see, it will remove 2 and minus 1. So it had what? Maxi and will it really work here? If it would work, so it would be great. Okay, so you can see here is like, okay, What we can see in this question is like, mm, and output any code, right? We don't have to minimize the number of operations. Yes. Okay. Uh, wait. Yeah, I clicked some solution, so let me do it after that. Means basically what I will do, you can all can see here something had been clicked in my mind. So yeah, let me click LL of fine in and okay. After that, what I'm going to do is like declare an vector. I will put things basically minus the last two elements. Fine. Yeah, in x and v dot v inside this x time is very less. Okay, so we have vector this, will denoting another vector. Wait a second, vi, which is, let me say that vi is like k, k which is k, and I will do that dot k dot e, uh, what we can say, k dot 1 minute. uh, just right now, let me see this. Okay, okay, fine. So I will check that a is equal to, so I will just take out minus one, and yeah, if it's ending of the and return else see what I'm going to do. Else I'm going to do is like how many number of operations would be. I am doing mm, fine. I am saying that p of I is greater than, sorry, p of n minus 2 or n minus 1. So if this is greater than equal to this, so I will perform how many operations? I'm going to replace three operations. Means like yeah, I'm going to do three out total how many elements minus operations and fine. And yeah, if it be on the other side of the case, so I'm going to put how many operations? N minus. Mm, wait a second. So on that case, we are going to perform n minus 1 operations and L. Fine. So yeah, LLM is n minus 2 and simultaneously LLM equal to n minus 1. After that, I'm going to the uh, which we are going to do is like, okay, no need this type of things. N minus 2 m minus minus, in which what we are going is like every time I'm going to print, or we can use this for loop I equal to 0 to I less than n minus 2 I plus plus. So here I'm going to print c of I plus, then I'm going to print n minus 1, then wait a second, x y z y n n and n minus 1, because here n is bigger. So it's bigger. Okay, so sorry, there it would be like smaller, smaller minus what it is like. Wait a second. A y minus a z. Okay, this is fine. It- I'm going to print simple it is, and here what's the thing which is going to do is like going to replace this till how many times? N minus 2 times only. This also, and here going to print one here n n minus 1, and after this one more operation we need to do is of n. We need to n and which one? N minus 1 minus of n minus 2, let it be. And so yeah, this is the operations which we will going to do. Let me check it out that this all things are working or not. So yeah, 3. Okay, we need to put some spaces also. Uh, okay, we had put some spaces also here. So fine. 1, 4 and 5, 2, 4 and 5. Fine. Everything is perfect. N minus 1. Let me change this with minus 3. 4 operations total. At the end, 5. Fine, everything is cool. So let's submit this solution. Wrong answer, pretest one. Why? What's this happening? Wrong answer, the array is not sorted after all the operations. How is this possible? Mm, -2 plus 1. -1 it is. So, yeah, yeah, yeah. No. Okay. Wrong answer. After all the operations. I literally thought to means like minus the last and second last, and every element should be less than this or maybe equal. But they both are negative, so it will increase this. Yeah, yeah, yeah. On that case, we need to be secure. -1. Okay, and -4. If we find the smallest difference, once okay, yeah, and minus and case of positive and minus on that also. Positive and minus case it could work. But if both are minus, behind that both are minus. -2, -3. So no, it would not work. It is not working right now. its difference is less than this, or equal to, but if it is more than this. Okay, means like some logic had been clicked to me, but it's not, it's only working for positive and negative, but not for both negative. Fine. If both behind that number is negative, so what should I do? What should I do? If both behind that number is negative. So wait a second. Let me see. Oh, nice. Mm, that thing I'm not clicking. Oof, I think contest is also now getting over only. I think I need to think about this. But yeah, today was like first question. I in first question means some difficulty was there. Not difficulty, but hadn't clicked so fast. Second question had been clicked fast. It was easy. And in third question, yeah, when some at the end some logic had been clicked and it is partially corrected logic, but not so. Okay, let it be. Means today I'm satisfied a little bit. At least I was able to see think about C, and yeah, in a upcoming contest I will give more contests, and yeah, it will increase means everything, like yeah, able to solve questions more fastly and productivity. So I don't think like after this anything, what could be the thing, uh, or minus minus. So the contest is finally get over. So I hope that everyone had gone today good contest. Fine. So let it be for today. Okay. Thank you so much. Bye.